solve, simplify, and factor. I got that you're finding the variable. Is that right? Okay. Finding the variable. And I'm going to add the word value to that. Finding the value of a variable. Okay. What else? What else do you know about solve? What else do you know about solve? In order to solve, we have to have something. What do we have to have? We have to have an equal sign. Must have an equal sign. Okay? What do we have to do to the two sides of that equal sign? We have to do what? The same thing. Okay? So we have to do the same thing to both sides. So, in the end, we typically have x equals what? X equals. What are we looking for? Yes, we are looking for a number. Okay, we are looking for a number. Now, right here by equal sign, I'm going to put in parentheses greater than, equal to, or less than and equal to, because just like you can solve equations, you can solve inequalities. Okay, so I just want to put that little bit in there. Now, we did a lot of this last chapter. We did a lot of that. We're going to do a little bit of it this chapter, but we did a lot last chapter. Last week, we simplified. Okay, so talk to me a little bit about simplifying. Talk to me about simplifying. What did we do last week?
I was just going to say you get it to the lowest form.
Okay, so can I put simplest form?
Yeah.
Okay, and when we are getting it to simplest form, what are we combining? Yes, we are combining like terms. Okay? We are putting everything together. I didn't spell everything right. Here we go. Putting everything together. Now, what does my answer look like when I'm simplifying? It's not an equation because we don't have an equal sign. Okay? What? It does. Okay? It can be a monomial. It can be a binomial. It can be a trinomial. Okay? So my answer is a polynomial. Okay? And in that answer, what types of things do I have?
You have a coefficient, you have an exponent, and shoot this up.
No, you're good. Okay, so you've got a coefficient, which is a number. Okay? What does that exponent go with? What is that exponent typically with?
The number.
Or what else?
Or up here.
Yes. Okay? We have numbers, we have variables, and we've got exponents. That's what my answer looks like. Okay? That's what my answer looks like when we're simplifying. Okay? Now today, what we're going to start doing is factoring. And you need to think about factoring as the opposite of what we did last week. Okay? So it is the opposite of simplifying. Instead of putting things together, we are pulling things apart. Okay? We are pulling things apart. We start with what we think of is the answer. Okay? We start with the answer. Okay? So we start with kind of the final thing that we did last week after we multiplied everything together and combined like terms. That's where we start. and we are moving towards what we thought of as the original problem. Okay? We are moving towards what we think of as the original problem, like where we're starting. We are working backwards. Okay, now, so some key words. For solve, you got to have an equal sign. Okay? For solving, you got to have an equal sign. If you don't have an equal sign, you're not solving. Okay? And your answer is a number. For simplifying, we are putting things together. And for factoring, we are pulling things apart. Okay? That's where we are. Okay, are we ready to get started? Okay. The very first thing that we do when we are factoring is we ask ourselves, is there something common to all terms? Is there something common to all terms? Now, very often, you are going to be able to factor out a greatest common factor and do something else. You're going to be able to do that. You're going to be able to do both. You're going to be able to factor out a GCF and factor in another way. Right now, we're starting with factoring GCF. No matter how many different ways you factor, you always ask yourself if there's a GCF first. Once you pull out the GCF, it makes it easier to manage. It makes it much easier to manage. Okay, so we're going to get started. What I'm going to look at first are my numbers. I'm looking at my numbers first. I have a 3, I have a 15, and I have a negative 21. 3, 15, and negative 21. What number is common to all of those?
3.
So I can pull a 3 out. Okay? So I'm pulling out a 3. 3 times what gives me 3? 1. 3 times what gives me 15?
5.
Good. Be careful with this one. 3 times what gives me negative 21? Not 7. Negative 7. Okay? Negative 7. Okay. Now, I'm going to look at the x to the 4th, the x to the 3rd, and the x squared. What I am looking for here is my lowest exponent. My lowest exponent. What is my lowest exponent?
2.
It's 2, and what's it with? What's the whole term? X squared is the whole term. So that's what I can take out from a variable perspective. I have x squared. Okay? So now I ask myself, x squared times what gives me x to the 4th? X squared. Okay? X squared times what gives me x to the 3rd? Excellent. Okay, be careful with this one. X squared times what gives me x squared? 1. Good. It's just 1. Now, what kind of 5 is this, since I don't have a negative in front of it? Good. Okay, so I'm going to rewrite my final answer. My final answer to this is 3x squared, okay, times x squared plus 5x minus 7. Is it okay if you put a 1 in front of that x squared in that if you had 1x squared plus 5x minus 7, would that be okay? Yes, it would be totally fine. Okay? So, this is our first GCF. Look at your numbers, then look at your variables. Okay? Let's do it again. Okay, I'm going to look at my 8, I'm going to look at my negative 2, and I'm going to look at my negative 12. 8, negative 2, negative 12. What comes out of that? All of the numbers. Look again. You got a little too optimistic there, but yes, you're good. Okay, 2. 2 comes out of all of those. Okay, now we got some negative signs we're going to mess with. 2 times what gives me 8? Good. Okay. 2 times what gives me negative 2? Negative 1. 2 times what gives me negative 12? Negative 6. Okay. Now I'm going to look at x to the third, x to the fourth, and x. I want to know what is my lowest exponent. The first. Good. So what can I take out? How many x's? Just one. So I'm just taking out x to the first. X times what gives me x to the third? X squared. X times what gives me x to the fourth? X cubed. Excellent. Okay, x times what gives me x? Good. And I'm going to write my 1 in there for this step. I'm writing the 1 in there for this step. Now I've got y squared, y, and y squared. So what's my lowest exponent? Y. So y squared, y, and y squared. Okay? Y times what gives me y squared? Y times what gives me y? Y times what gives me y squared? Good. Okay, now I'm going to write it all pretty like. Okay? 2xy, that's my GCF. 4x squared y minus x to the third. Would it have been okay if I put minus 1x to the third? Yes. Minus 6y. Okay? So what we have here is we have a monomial times a trinomial. Yes, 3 terms. Okay? So we have a monomial times a trinomial. We are breaking it down. Last week you would have started here. So last week you would have started here and you would have moved to this. We are doing it backwards. We are working backwards this week. That is what factoring is. We are breaking it down into original pieces. Okay? Now, can I move to the next one? Good? Okay. What we're going to do now is we are going to factor by grouping. Factoring by grouping. Factoring by grouping is probably what you're going to use the most because when we factor trinomials, we're going to turn them into 4 terms. So knowing how to factor by grouping is super, super helpful. So what I have right now is ab squared minus 4b squared plus 3a minus 12. So the first thing I look at is the first 2 terms. I'm going to look at that right there. So I'm going to ask myself, is there anything common in first 2 terms? Okay? Is there anything common with my numbers in the first 2 terms? I have 1ab squared and negative 4b squared. Is there anything common there? No. Is there anything common with my a? Do I have an a in both terms? ab squared minus 4b squared. Is there an a in both terms? Not in the first two. No, there is in the third one, but not in the first two. Is there anything common with my b squared? Yes. So I am going to take out the b squared. That's what I'm taking out. Okay, so I'm going to have b squared on the outside. Okay, b squared times what is going to give me ab squared? A. Okay, b squared times what is going to give me negative 4b squared? What am I going to multiply that by? It's a number. What do I multiply it by? Negative 4. Okay? So, what I did there is I just looked at the first two terms. Is there anything common in the first two terms? The second thing I do is I look at the second set of terms. You do not need a b because I've got b squared right here. Do you see that? That's a good question, though. So both of these are b squared, so I was able to take b squared out. Excellent, excellent eye. Second set of terms. I am going to do the same thing. The second set of terms. So now I am looking at 3a minus 12. There's not an a in both of them, but is there a number that I can take out of both of those? 3. Okay, so I'm going to pull a 3 out. Okay, so I've got plus 3. 3 times what gives me 3a? 3 times what gives me negative 12? Good. Now, what we're looking for at this step is a GCF. Okay? That a minus 4, that is a GCF to b squared in 3. Okay? So we are looking for a GCF right there. Notice that the a minus 4 match. If they don't match, it's not factorable. You gotta come up with a new plan. Okay? In this course, it'll be the quadratic formula, or we'll say it's not factorable. In 144, for those of you that go on to 144, it will be synthetic division. Okay? So I've got b squared times a minus 4 plus 3 times a minus 4. So I am going to take out an a minus 4. Then I am left with b squared plus 3. Okay? I'm left with b squared plus 3. Now, students consistently say, Alicia, but I have a minus 4 twice. Why do I not write a minus 4 down twice? Okay? I get that question a lot. Now, I want to show you something. Okay? This right here, this a minus 4 times b squared plus 3, that's our final answer. Okay? That's my final answer. But I'm sorry? We are going to do FOIL. Okay? So I'm going to rewrite this as b squared plus 3 times a minus 4. Now I'm going to show you a step in FOIL that we don't ever write down. Okay? What does the F and the O stand for in FOIL? First and outer. Okay? We're just looking at the F and the O. Okay? So my first term is b squared. Okay? And as my first and my outer, I am going to multiply that times a and negative 4. That's my first and my outer. B squared times a and b squared times negative 4. Do you agree? What we are doing is that right there. Okay? We just don't write that down. We just write down b squared times a minus 4 times b squared. We just skip that step, but that's what we're doing. Then, what are the two next letters? Inside and last. Okay? So my inner is plus 3, and I've got to multiply 3 times a and 3 times negative 4. Okay? And again, we don't ever write that down, but that's what we're doing. When we're doing F and O, we're multiplying B squared times these two numbers. And when we do I and L, we're multiplying the 3 times these two numbers. Then, so that's a step when we're working backwards that we don't always process when we're foiling, but it is what we're doing. Sometimes you see it more clearly when you're multiplying a binomial times a trinomial, because you write each one of those out. Okay? So this is the step that we do, b squared times a, b squared times -4. Okay. So last week, this was the answer. Okay? This week, where we started is the answer. We're working backwards. Okay? Here we go. Let's try this next one. What do you notice about the two middle terms on this one that you could already do if you wanted to? You could, okay? You could combine like terms here. Then you have to factor it as a trinomial, which is fine. You certainly could, but that's not where we are right now. We're not factoring this as a trinomial. We're factoring this as grouping. So what do we pull out of the first two? What do we pull out of the first two? Good. It's not a negative x, no. It's just x. Okay, you want to keep that first x positive as much as you can. Okay, x times what gives me x squared? X times what gives me -x? Excellent. What do I pull out of the second two numbers? Okay, 5 times what gives me x? 5 times what gives me -5? Excellent. So my final answer is x plus 5 times x minus 1. Okay? X plus 5 times x minus 1. Okay. Say that again. Why is it?
Why do you get x plus 5 and x minus 1?
Okay. No, you're good. You're good. It's okay. Here is an x, and here is the plus 5. Okay? So these two make one of the factors. This is the other factor.
Oh, gotcha.
Okay?
All right.
Good question. Okay. Are you guys ready to try? Okay, I want you guys to do these two. Factor by grouping. Factor by grouping. Okay. How we doing? Okay. What comes out of the first two? X. Okay, x comes out of both of those. X times what gives me x squared? Good. X times what gives me 2x? Okay, now, Do you see how I have a negative value right there? Okay, that is an indication that you need to pull out a negative. Okay, so instead of taking a 3 out of both of those, what am I going to pull out? Negative 3. Okay, so I have minus 3. Negative 3 times what gives me negative 3x? Negative 3 times what gives me negative 6? Excellent, positive 2. Because a negative times a negative is a positive. Okay, so my final answer here is x minus 3 times x plus 2. Now for this one, half of the work is already done for you. Okay, what's one of my factors? I don't know what I dropped. Oh, that's probably what it was. It's a peak marker. I'll get it in just a second. Okay? What's one of the factors? X minus 3. Okay? What's the other one? Y plus 2. That y plus 2 is a GCF. Okay? You're pulling that out of both of them. And then you're left with x minus 3. It's a different way to think about GCFs. It's a different way to think about GCFs. Okay? Okay. Now, we're going to talk about difference of perfect squares. Can I move off this screen? Okay. We're going to talk about difference of perfect squares. Now, before we can talk about difference of perfect squares, we need to talk about what a perfect square is. What is a perfect square? So, if I have 1 squared, what is 1 squared? 1 times 1. Okay. 2 squared. 3 squared. 4 squared. 5 squared. 6 squared. Okay, 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. Oh, excellent. 12 squared. Good. Okay. These numbers here are your perfect squares. Okay? Those are your perfect squares. These numbers, like the 2, the 3, the 4, that is your square root of your perfect square. Okay? That's your square root of your perfect square. So if I ask you, what's the square root of 36? What's the square root? 6. Just the 6. Okay? Just the 6. So that's what a perfect square is. That's what makes it perfect. Now, can I erase the perfect squares? You guys got them? Okay. Now, what you want to think about is when we had a minus 2 times a plus 2. When we FOIL that, we got a squared plus 2a minus 2a minus 4. What happens to the 2a and the minus 2a? They cancel out. Okay? So I'm left with x squared minus 4. Now, when you were multiplying or FOILing the difference of perfect squares, it wasn't necessary for you to be able to identify that that was a difference of perfect squares. When you FOIL it, it is necessary for you to identify that this is the difference of perfect squares. Okay? So, this is the definition of the difference of perfect squares. Okay? I have a squared minus b squared. These are the things that have to happen You have to be able to identify these three things for something to be a difference of perfect squares. And this is called a special product. Okay? This must be perfect. Okay? It must be a perfect square. Okay? This must also be perfect. Okay? It must be a perfect square. And it must be combined with subtraction. If it is addition, this doesn't work. It must be subtraction. That's what the word difference means. The word difference means subtraction. If you've got a plus right there, it cannot be factored. If you've got a plus right there, it cannot be factored. Okay? So, what is the square root of x squared? What times itself gives me x squared? X. Okay? What's the square root of 16? 4. Okay, so I am going to write that down twice. One of them is going to be plus and one of them is going to be minus. Whoops, I didn't write the 4 down, sorry. Okay, so x plus 4 and x minus 4. Difference of perfect squares. Now, here, my 4 and my x is perfect. What's the square root of 4? What's the square root of x squared? What's the square root of 25? Okay, and what do I have to do inside? A subtraction and a good. Okay, that's what you've got to do. Now, I think when I was doing perfect squares, I forgot to mention x squared is a perfect square because it's x times x. So x squared is perfect. Another one that's perfect that we forget is perfect is x to the 4th. The square root of x to the 4th is x squared. X to the 4th is perfect because x squared times x squared is x to the 4th. Okay? Okay. I'm going to give you 2 minutes to do these. Okay? I want you to take the GCF out first. Both of these have a GCF. Take GCF out first.
Is that a 36 or a 3B?
It's 36. 9x squared minus 36. 48y to the 3rd minus 27y.
So we're factoring it, or?
You're factoring it. But you can do a GCF and you can do difference of perfect squares. What's the GCF on the one on the left? It's higher than 3. It's 9. Taking out that GCF makes it easier to solve. What's the GCF on 48y to the 3rd minus 27y? What's the GCF on the one on the right?
3.
Yes, it is a 3. And what else? 3y. Okay, 48 is 16 times 3, and students often don't catch that one. Okay, so now that you've got the GCF, go ahead and factor those. What's the square root of x? Or I'm sorry, what's the square root of x squared? Square root of x squared. Okay. Square root of 4. Okay. One of them's plus, one of them's minus. What if I had done minus and plus? Would that have been okay? Yes, it would have. Okay. I'm going to keep my 3y out here. I'm going to keep my 3y. What is the square root of 16? What's the square root of y squared? Okay, what's the square root of 9? 3. One of them's plus, one of them's minus. Okay?